Record. Ah, good. All right, so I'm here again doing a repair here on a HP, and it's not turning on. So I have a guest, as you can see, he's in the background now with some jobs that he traveled with for me to repair. So I'm going to start the repairing process now. So I'm going to first check on this board. I have about 5 or 6 maybe, I don't know. Alright, so as plugging in the charger, I see I get white lights. See, I got the white light, but I'm not taking any current, as you can see on the DC power supply. Oh, let me press the switch. Alright, the switch is here. So I'm pressing and I get 50 milliamp, as you can see. Right, 50 milliamp there. Alright, so I'm going to check some voltages. So first I'm going to check RAM supply. We don't have RAM, so oh, it's off. Alright, so I'm turning it back on. RAM supply is there or not? No RAM supply. I have 5 volts. Yes, I have 5 volts. 3.3 volts is there? No 3.3 volts. I have 1.0 volts. No 1 volts. Alright, so I'm not getting any voltage at 3.3 volts coil. One light. Ah, good, very good. Yeah, 2 views, 1 light. Ah, yeah. Alright, so I'm going to check, cool check now. So first I'm going to check 1.2 volt RAM supply. I get 118, 19, 20. Alright, I'm taking 3.3 volts. As you can see, I'm getting a dead short to ground. Right, could it be that the CPU is dead? All that. All this. Oh. Yeah. All right, so I'm gonna remove the heatsink. Oh, normally when I check bias chip pin number 8, let's check and see if we have any form of any liquid corrosion or any burn mark first. Let's inspect the board. So as you can see, I'm now inspecting the board and I don't see any burn. I don't see any form of liquid corrosion or intake on the board. Alright, up this side, also good. On the switch area here, on the LAN card there, this is the audio. Alright, this is RAM supply, PWM IC. Let's check in the CPU PWM area. All good here on the CPU PWM section. So the board is perfectly fine in terms of the appearance. And I don't see anything indicating that it could be something that could lead to the problem by visual inspection. I'm looking in the 5 volt section here, no problem. So I'm going to remove the CPU heatsink. And I'm going to burn the board to see if the heat is coming from the CPU section. Then I can call it a day with this one, because I don't have the CPU for this one. As you can see, it's a 7th gen CPU. Right, this is a KB Lake CPU, as you can see. Right, this is a KB Lake. No, it's an 8th generation, as a matter of fact. It's a Whiskey Lake CPU. Right, this is a Whiskey Lake CPU. Right, 8th generation. Right, so I'm now checking bias chip pin number 8. Bias chip pin number 8. and it's dead short, as you can see there on the multimeter. So I'm going to solder a wire right on this pin number, and then I'm going to head over to the thermal camera to see if the PCH section is dead inside of this Coffee Lake CPU. Alright, so I'm getting the wire ready. Right, so I'm going to give 3 volts. I'm going to give 3.3 volts on this line, because this line for the PCH and the BIOS standby rails are the same. They share the same power rail. So I'm going to give 3.3 volts on BIOS chip pin number 8. My flux is a bit hard. Let's go under the microscope for this one, shall we? Alright, so this is the BIOS chip pin number 8. So I'm just going to add some flux here on that pin. My flux is a bit worn, I believe. Let me see if it is clogged up. Let's try now. Oh, there we go. I had spilled too much on the line. Oh. Alright. Getting the soldering iron ready. That's chip pin number 8. First of all, I'm just going to feel it in my hand. Right, so I'm going to give power now. And I'm touching here to see if the PCH is getting hot. It's not getting hot, and I'm taking 3.8 ampere of current there. The other DC power supply is not shown, so I'm going to head over to the thermal camera. Excellent. All right. Okay, so and I'm getting the software ready for the thermal camera. Alright, so I'm going to head over to the camera. So I'm going to give power. Let's see where it's getting hot. I was feeling the PCH section, but it wasn't getting hot. Oh, ground. Alright, so here we go. 1, 2. Alright, so I'm now checking. I'm going into seat mode. As you can see, down this section here is getting warm. Somewhere here is getting hot. Somewhere here is getting hot. Alright, I'm going to remove power. And I'm going to flip the board. And I'm going to put it to that part that is getting hot. As you can see, let's reseek. I'm going to give power. That's inside of the board. Is that possible? Oh, here is 72 degrees. Let me see what is that. And that part of the board is getting hot. As you can see, 74 degrees. So I'm going to check on the next side. So somewhere down here is extra hot. Right, and it's pointing to this coil. Alright, so I'm going to give power again. Let me reseek. Alright, so I'm going to give power. And that's it. And that's a capacitor. That's a capacitor there that's getting hot, as you can see. Right, so right here at the capacitor here, somewhere here is getting hot, as you can see the cursor. Let me give power again. Look at the red cursor. It's going to point directly there. It's 92 degrees, 96 degrees, and it's right there. So most likely it's a cap that's shorted. Okay, so it seems as I thought the CPU was broken. I thought the CPU was dead because it's a common issue for the CPU to go and die. Right? So I'm going to go under the microscope and let's see the color of this capacitor. As you can see, let me focus. Right, so I'm going to add some alcohol and I'm going to put some alcohol right here on this one, right here, and see if it's going to evaporate quickly. Ready? 1, 2. As you can see, did you see that? Let me go again. Can anybody tell me which capacitor is bad? It's 2 of them that are getting hot. Can anybody tell me which one is getting hot? The chat there. Chat. Can anybody tell me? Alright, so I'm going to go again. And it's this one. As you can see, the crack is there. Alright, this one is cracked. As you can see, there's a line there. Let me see if I can zoom in some more and get this focus. It's not focusing. I'll go out a little bit. As you can see right here, there's a crack here. There's a crack right here. So this capacitor is broken. It's a line. It becomes a wire. So I'm going to remove it. Adding some flux. So this is a lucky CPU, we can call it. So I'm just going to remove it now. So I'm going to lift one leg, just one leg. I didn't want it to remove it completely, but that's fine. Alright, I'm just clearing that section there so I can solder a new cap. Alright, so I'm gonna go back out to the overhead camera. Alright, so I'm gonna check bias chip pin number 8 again. Alright, so I'm gonna check bias chip pin number 8. If the short is cleared or not. And we have 307. So the short is cleared. That's good news. That's very good news. So that's what I want. We don't want a dead CPU at the moment. Can't afford that. So I'm just removing the wire there for testing. Right, so I'm going to solder a new cap, and this is a 0603 capacitor. Most likely a 1 microfarad capacitor with about 6.3 volts. So I'm just getting the capacitor now. It's a here and you like it, eh? Tough. Yeah. Around seem like it. Alright, so I'm getting the capacitor here with the correct capacitance. Here it is. Right, I use it so much. Let's go back under the microscope for this one, shall we? Alright, so here we're at the spot. Right, so I'm going to take out the new cap. Where is my tweezer? Alright, how many I have leave? I have 3 leaves. That's 5. I have more. So I'm just gonna solder this one back in on its position. Alright, there we go. Alright, so I will now clean it with some 99.9. Alright, so let's recheck again. Some cold check. So I'm checking that coil 3.3 volt. As you can see, I'm getting 300 now. Right, 1.0 volts. Okay, that's okay. Alright, VCC ST, VCC IO. I get 2. No, this is VCC ST. Sorry, VCC ST and VCC IO. Right, and this is CPU core, and this is the graphics core, VCC GT. As you can see, we have RAM supply, which is also good. Right, 5 volts. Right, that's okay. Right, 1.8 volts. 1.8 volts is here, and 1.8 volts is okay. I'm getting 349. So now I can apply power to the board, right? So let's see what we get. Remember, we're getting white lights before. See, white light is there. So I'm going to hit the switch. So let's take a look at the current. Now we had 450 milliamp, right? And that's good. Now I'm going to put back the heatsink on the board, on the CPU. Don't want to burn the CPU. Alright, so I'm just going to connect back. Let me get back some thermal paste. Some fresh thermal paste on the CPU. Hey, Rafiq Ahmed. Hey, yes, how are you? Right, so I've just applied some fresh thermal paste there. Alright, so I'm just going to put back the heatsink, and then I'm going to do hot checking. Alright, so as you can see now, the heatsink is in place. So let me give power. And I'm pressing the switch now. As you can see, the current now is 460 milliamp, 300 milliamp. Oops, the wire moved. Let's go again. All right, so let me. You keep blocking me on WhatsApp. No, I didn't block you on WhatsApp, Richie. I have a lot of work, so I don't have time for phones at most times. The phones are a distraction. All right, so I'm going to check some hot checking now. So we have RAM supply. Yes, 1.2 volts is there. Right, this should be 1.0 volts. Yes, 1.0 volts is there. Right, 0.95 or 0.1 volts. 1 volt, this is VCCST, VCCSA. CPU core is there. Yes, and we don't have a CPU core. We don't have a supply here. So once it's the CPU gets all working conditions, supply reset on the clock, it will read the BIOS. After reading the BIOS, then it will read the RAM. After the RAM is passed, then it will initialize the graphics card, and then this voltage will only come maybe within a 100 millisecond range, and then powers off. Right? So this is how the VCC GT section works. So this voltage will only be applied after the RAM has passed. So if the RAM is not passing, then we won't have this voltage. So as you can see, I'm keeping my meter on VCC GT, and I'm going to see if that voltage come within a fraction of a few milliseconds and then go away. It's very difficult to capture the signal with a multimeter. You have to use an oscilloscope. So right now, as you can see, it's fully on. So this signal already passed me. So the only way to capture the signal is through an oscilloscope. Okay? So I'm going to connect the unit to the case. There we go. So I'm now assembling and see if I can do a full check. Is this correct? I don't think so. Alright, so I've now assembled. That's how I got it. Alright, so I'm going to power the unit now. So let's take a look. Oh, yes, Richie. Everything is fine, Richie. You don't have to worry yourself, Richie. That's Richie from Ghana. Alright, so I'm going to give power now. As you can see, the screen got dark. Alright, it's powered off. It's now resetting the RTC well section inside of the CPU. And we have display. As you can see there, we have display. Alright, so it's now booting up. And it says no boot device. Did something wrong with the hard drive? Did you know something was wrong with the hard drive? Let me see if I connected it. Yeah, I connected the hard drive. Oh, we have two hard drives. Oh, sorry, it was my mistake. I didn't connect this. This is the primary hard drive. This is your job? Is that your job? Oh, really? Hans himself, not Mr. Reed, right? Okay. So if it's Mr. Reed, he doesn't really care about Mr. Reed's job, right? Mr. Reed don't really believe in motherboard repairing anyway. Yeah. Alright, so I'm connecting this and then try again. Alright, so we should get some. Now the current has increased as it was 400 to 26 milliamp, 260 milliamp before, so it should work. Alright, this first power off, initialize RTC well. Okay, we have display now. And we should see, we have the HP logo now. So as you can see, it's now, oops, it shut off. My wire is not so 100%. I should turn on back immediately anyway. Sorry about that. Alright, so there we go. We have our HP logo and it's booting up. I think the wire got slipped out of the socket by moving. I think I have some slight wire in there that I need to fix. Alright, so there we go. So it's now booting up. How do I get board view for this machine? Which machine is that, Richie? You are talking an Apple computer system or this HP? I don't think you fix PC, you fix Apple, right? Alright, this one is taking a while. Alright, there we go. So we are in the system now. Should see getting Windows ready. Now here's the mouse. It's a bit slow. Alright, there we go. So please wait. And there we go. So we're on the system now, as you can see there. Alright, there it is. So that's a done job. So I've shut on the machine. All right, so I'm going to do another one. What's wrong with this one? Oh, he said that it has a burn on the LCD connector here, and it's not giving any picture. Let me see if I can plug in the charger. It's a Type C, or it's a Type C machine. So I'll need to plug it inside of the Type C hub here. So I need a board view for Alienware. What Alienware? Which one of the Alienwares? And what's wrong with the unit? Okay, so I'm plugging in the power now, as you can see. What's going on here? So it's boosting to 20 volts. It's boosting, and I get 17 volts. I get 2.9 ampere, but it's not showing anything on the screen, as you can see. There's no image on the screen. All right, there's no image on the screen there. Completely blank. All right, so there's no image on the screen. Oh, it died. It's a Dell. So there's no image on the screen, as you can see there. So we have a burn on the LCD connector. I'm getting caps lock, as you can see. I'm getting caps lock, so the system is fully on and working. So is that good news? So I'm plugging in my USB keyboard. As you can see, I'm getting caps lock. So that indicates to me that the system is fully functional. But we're just not getting an internal display there. So most likely the external display should be working, right? All right, so I am going to take it apart now. Turn it off. Right. Okay. All right, so I'm going to disassemble the unit. 23 views, 3 lights, 4 viewers. Very good. Just not sure that. Easy. Better than testing with a keyboard. I think you make a USB tester to test the display. I think if you make a USB tester with ST-Link version 2 to test the display is better. Oh, well, it's just a shortcut way of quickly analyzing if the display is there or not. What's that? What? Oh. All right, so what the heck is going on there? Anyway, so well, the keyboard method works pretty fine for me. I've been using it for years. Alright, so here we have a burn right here. Alright, this section here is burnt out. Was it liquid? Oh, you're not sure, just burnt? Rain. Oh, it was caused by rain. As you can see on these capacitors here, you can see some oxidation here on them as well. And this section is burnt out completely. I should believe that this section is 19 volts. As you can see, we have the fuse here, F5102 coming through a fuse, and that's going to power the sensor. The entire area here is caused. It should cause no backlight though. Maybe the LCD flex cable is broken. What's causing that? Annoying. Alright, so I'm now going to remove. Oh, so luckily the LCD flex cable wasn't burned. Else they will have to replace the entire flex. So right here is all good so far. Alright. Alright, let me take it apart and see what I'm getting. Well, we have a lot of disassembling now here to do. Oh boy. First start from this side and then go all the way to this side. Alright, I'm just disconnecting everything first that I can see that can be disconnected. Alright, power switch, webcam, trackpad, and so forth. Alright, so let's start. Alright, all mics are there. About 38 minutes. I'll stream maybe for an hour and a half. Don't think I need no more than that. I think I'll stream for an hour and a half. I don't think I need more than that. 1.5 hours enough. Sufficient. Oops. Oh. Alright, so this is a 40 pin connection for a regular screen, I believe. Oops. I think I just smashed the light here on the board. Thought I broke it. It was on this. Anyway, focus is here. Alright, so we have a burn here. As you can see, it's caused by liquid. As you can see, some of these capacitors here are oxidized. And this entire piece is gone on the LCD cable, so I'll have to remove this, and then I have to run a wire and use a UV mask and mask back this area and see what we can do here. Alright. So much clear. Alright, this fuse is, oh, we have a short here. We have a short. The fuse is good. Fuse is good. Maybe this cap is cracked. I have a short here, I believe. Yeah, this is a short. All one of these caps are cracked. I'm just removing it. Short is still there. Removing that one. Short is still there. Yes. I will remove this one. Short is still there. Yes. Remove this one. Short is still there. Yes. Short is there. Short everywhere. Serious. Okay. All right, let me check under the next side. Have some diodes here and some fuse. Let me check this fuse. Is it good or not? Yes, this fuse is good. Alright, so I'm going to remove this connector. Alright, so it's now off. I'm enjoying watching pro like you, and you are very professional person. I have to go, brother. See you next time. Okay, my friend. See you another time. Alright, so I'm now tinning the pads here with leaded solder. I'm just cleaning the air here with some 99.9. I'm now 49 minutes in the stream. I have roughly half an hour left to go. Alright, so let me check again here on this side. I'm not sure if it's gonna clear. Seems like it's gonna still have a short. It has increased a bit. Alright, at the fuse here, still have a short. One, two, three, four, five. So it's one. What is that? Don't like hear that sound. Alright, so that's 1, 2, 3, 4. So those 4 pins there that is connected to the screen backlight power supply. Alright, let me remove this fuse. Okay, this side is clear, but this side is a problem. This is the screen power supply, LCD VDD or LED VDD. Oh, here is the screen power supply. Right, this is the screen power supply capacitors here. Right here. These are caps for the screen. 3.3 volts will be here. LCD VCC or LED VDD signal. Screen power supply. But I need to see what's causing the short here. I think that the via is actually mixing with the ground layer. Here. If I supply 20 volts here, maybe it spark. It's cleared? No short? Nothing here? It's not working? I'm not getting anything now, so it seems as I scraped away the part that's actually grounded. So I'm just going to use some UV mask and I'm going to apply some UV mask glue here to see if I can shield this section here from touching the ground. Right here, as you can see, this section here, we don't want it to mix with the ground layer here. Right here is grounded. This is ground. So I'm going to put some UV mask in this section. As you can see, I'll have to fly some wires and catch 4 pins or group them together for the 20 volts for the screen backlight power supply here. Right, because there's actually 20 volts coming here with a lot of current. Right, and I have to make sure that I shield the hair properly so I don't get any grounding. Alright, so I think we're good now. So I'm just going to get some UV oil. Alright, so I'm just going to apply a small amount. You don't need to apply a lot because it's going to take too long to cure. That's about it. You don't need no more than this. Alright, so I'm going to use the UV light to give it a 5 or 4 minute cure. I have one that can cure for maybe about a second, 10 seconds I believe. See it? It's a brother. So I'm going to connect the power and I'm going to give it. We have on off, we have delay and second. So I turn it on, I'll give it that and see how quick it can cure it. Is it here and you love it? Easy. Just a record that. I don't know, 4 likes. 4 likes, 30 views. Most Saturdays. Well, just that. Alright, so it's now finished. Let's go back under the microscope and see how it looks. If it's hard enough. Is it hard enough? Need some more time. I'd say I enjoy watching pro like you. Here I'm a little from my battery each now. I'm a mic. I have no. Huh? You want a screwdriver? You want a screwdriver? That's a Lenovo? Then I read it. I don't have to watch here. 64 or 32. I think it's 64 that's coming. Everything is a Hansen? Come, but. I say you love Hansen, man. Hansen, your boy. Second, no. Hansen at the shop? Really? Interesting. Why? You're not ready anymore? As in school, my study? Where am I learning? Electrical? So I think it's time, yeah, my can tell me, say, we want to do the electrical thing. Yeah. Alright, so let's go back under the microscope. Okay. Alright, it's hard enough. Alright, so I'm just gonna check on the output here for the 19-volt screen backlight power supply. And I'm getting oil. I think that should be good. Alright, so I'm checking here. Alright, I'm getting oil, that's good. Alright, screen power supply. Alright, that's also good. Alright, this is for the camera. This is for the camera coil here. Microphone, sorry. Yes, microphone or camera, I believe. Alright, that's good. Alright, and we have EDP signal here. So we have 1 pair here. Is it 1 pair? We have 1, 2, 3, 4. So it's a 4K. So this is a 4K. As you see, we have a pair. 1 here. This is 1 pair. 2. Sorry, I got mixed up. So 1, 2, 3, 4, and this is EDID clock and data. So that's a 4K. So that's a 4K display out there. So alright, this motherboard has the ability to install up to 4K. That's a 1440p resolution, right? Or 16K, 4K, and 1080 and regular screen resolutions, I believe. Yes. Anyway, I'm going to put a new connector back on this thing. See if I can find a 40-pin connection. This is a 40-pin narrow connection. I'll see if I can find one. What time now? 2 o'clock. Alright, here. Ain't early, man. Come on there, so. Run, saying dash him food. Dobby. Eh? Come tomorrow? Oh, tomorrow Sunday not go work tomorrow? Can I have to put in the work, eh? Mean, Dobby. This is a 30 pin. It's a 30 pin this. Oh, it might have to be a 40 pin now, Lord Jesus. Boom. Screen. It's supposed to have one account. This one here. So one this. Alright, so this one is a broken screen here. So I'll have to take it from this one. Should be a 40 pin. Let me measure them up. Okay, so this looks like what we want. This looks like what I want. Where are you, screen? Where is it? Alright, so this looks like the connection I need. I believe. Is it? Is it here on? Is it the same thing, right? Yeah, it's the same thing. So let's remove it, no? Alright, so we're going to remove this connector here from this old broken screen. I need to put it back because this is actually a test screen for testing my broken, for backlight purposes. So see if I can get some to order. Alright, so let's take this little thing apart. Alright. Yeah, around. Feel like with a piece of Kentucky now. Just a little bit stronger, baby. Oh, my love keep growing stronger. You know that song they hear on? Yeah. Really?
No?
You need to come here more often, man. Eh? I said, you need to come here more often to learn.
Yeah.
You're on same one, learn. Alright, so we're going to move this now. So I've tinned it with some leaded solder so you can use less heat. Because I don't want to melt the plastic on the inner part of this connector, or else the repair is kaboom. And I don't think I have another one at the moment because this one is a rare connection. It's a 40 pin narrow, and this is coming from a broken touchscreen, as you can see. Alright, so let's go. Taking it from this side. Alright, so I'm going under, and yes, we're there, we're getting there. Right, I'm now at 300 degrees. No more than 300 degrees for this one. Alright, there we go. I'm under and I'm lifting. Ah, there we go. Comes right off. Alright, let's take a look at it for any deformation. Is it deformed? And it's nice and clean. Perfect. Alright, so I'm now going to put this on the board. Alright, so we have a 0.5 millimeter gap between each of these pins. Alright, 0.5 millimeter. So this is a 40 pin, 0.5 millimeter LCD connector. Alright, so I'm now just adding flux there for the connector, and I will do a jog solder, and then that should conclude that soldering process. Alright, so I'm just going to clear this little solder here, this little blob here, right here. I don't want this bridge. That can give me a nightmare. So let me remove it from now. There we go. It's now removed. Alright, so I'm going to put it in. Alright, I have another bridge right there. Alright, so let's do this, shall we? Alright, so I'm just going to catch this side first. Alright, I'm going to use the tweezer. The tweezer would be a more better grip or a maneuver. What time is it now? I'm 1 hour and 8 minutes in my repair. I think I have 7 more minutes left. 20 more, 25 more minutes left, I believe. I'll use heat first. I'm going to use hot air first. I'm setting my temperature to 300 degrees. Don't want to melt the plastic. Oh shoot, I licked off one of the caps. When did that happen? Didn't see that. Alright. Now I'll just use some hot air now and then I'll just finish off everything. Alright, so it's now so the connector is now descending. Right, the flux, the solder is getting shiny. And it's now descending and it's in place, as you can see. Right, so I'll now just go over each pins with the drag solder technique. And finish it off. Here we go. Oh, I'll just move one more cap there. Alright, so I'm done there. Alright, so I'm just catching these last legs. And this should be a ground leg. Let me remove some UV glue catches this pin. So I'll have to scrape away that to expose the solder pads. And there we go. Alright. And that's it. Alright, so I'm just going to clean with some 99.9 and then I'm going to put back these two capacitors here, which is most likely for the auxiliary connection here for the screen or the graphics card to read the screen information. Right, so after the CPU and the graphics card is initialized, then the graphics card will read the screen information through these two lines here, which is AUX negative and AUX positive, right? So this information is similar to an I2C line, right? So this is a high transmission of data which is passing through these coupling capacitors, as you can see, right? So these capacitors are connected to the signal, and one side is connected to the screen. So these are basically blocking low frequency and passing high frequency. That's the typical characteristics of a capacitor. So it blocks low frequency, passes high frequency, right? And it's basically acting as a differential mode filtering as well. You understand, Matthew? You understand? Alright, so we're just checking all the pins, make sure that all the pins are connected as I'm dragging the needle across the legs here, making sure that there's no leg that is going to be moved and they're all intact, so that indicates that the soldering is complete. And then I will connect back these two coupling capacitors here for the AUX negative and AUX positive. As you can see, this connection or this board supports up to 4K display, and this board is very soft. It's very sensitive to heat. You can't put too much heat on these types of Lenovo. These are called LCFC board, which are developed in Taiwan, are manufactured in Taiwan, and they make these boards very soft. If you don't know what you're doing, you'll melt every single thing off this board if you put too much heat on the board. You maybe even popcorn the board or deform it. That's how. See, look, I'm also removing it, and look at this. I'm not putting any heat on it, and it's also moving the fan connector here. See, that is speaker connector. That's how volatile. This is how vulnerable this board is to heat. You can't put too much heat, as you're gonna damage the board. The LCFC boards. All right, so I'm gonna get some capacitor to fill this area here, and then I'm gonna jump a wire. So I'm gonna put back the fuse here, right? I'm gonna put back a cap here, and then one here. I'm not gonna put these here. So I'm just gonna put 1, 2, 3 caps and a fuse, and that should conclude the repair. And I'm going to run one wire and just create a nice blob of solder right here and join them with one wire, and that should send 19 volts to the screen. Backlight power supply driver IC. Okay, so I'm going to get the caps here. I'm going to solder back some caps here that were misplaced during the soldering. I didn't realize that the solder iron was so close to this section here. So I'm going to get some capacitors, and these are coupling capacitors. Doobie. Here on same learn. Alright, so I'm going to start. Right, I use. No, look at the corner that says it. No, man. Behind this. No, that can't manage it. It can't manage here, and it cannot manage. Oh, yeah, there's some put it, man. Look. The best spot that I find when we can put it, isn't it? Mr. Heron. Yay. Yeah, Heron and Reedy. Oh, good. You stop fight now? Still a fight? You stop fight, yeah. Yeah. Heron and Mr. Reed still fighting. I forgot the day now, let me see. Yeah, do a hinge repair. And the man come in, I know him coming late more time. Man, the man must stop taking me here for you. The man watch here and him. And I say, what the man watch here and so? You might watch you and me watch him, you know. Me I watch him, I watch. Alright, so I have a donor board here. I'm going to take these capacitors off. You can't put random capacitors on this line because these capacitors are very small in capacitance, so you have to be careful. Right, and this is a 0201, I believe. Yes, these are 0201 capacitors in size. Right, all of them are 0201 capacitors. And they have 0.001 almost to a picofarad because it passes high frequency, so they are coupling capacitors which transmit high data signals. So I'm just going to take two. I think I need more heat. Well, I'm now 1 hour and 20 minutes. I have roughly 10 minutes. Oops, is that blown away? Oh, no, 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 here's it. There we have one. And I have two. It's gone? Alright, that one blew away. Turn on the temperature. Alright, that one blew away. Yeah, but it's to find it. Some water corrosion here. I'll have to get another one. Where did I put that board? Alright. Alright, here's one more. So here, I remember the last time you say if fuse blow away, you never have any more fuse. You nearly cry, don't it? That make it hot, you know, so that will fix the problem, you know, and it go last. Rough, you know, and no more. Alright, so I think that's done. I'm going to put back the fuse. And the fuse is still good. Alright, just to catch it that it don't blow away. Let me perfect it now. Alright, now let's check the resistance now because the fuse is installed, so the resistance will be carried over from the board to the screen backlight power supply. Right, so I get 360. Excellent. Remember, I was getting open loop here. I wasn't getting a resistance here. So this is what I want. This is the common point power supply. So where the battery and the charger share the same power source on this line. Right, it should increase as it gets cooler. Right, slowly increasing. So the cooler the board, the higher the resistance. Right. I'm now 383, and that's what I want. So everything is okay. So now I can put back these small filter capacitors now. So I will now just add this one here. Just two, I think I will need. I'll just add two. So one here and three and two here, and these two small ones here. I won't add the third one. Just a fourth one, sorry. So those three. 1, 2, and 3 here. Right, so it's 1, 2, 3. So I'm now tinning the pads. Alright, to install new capacitors here. This one is a 0402 and this is a 0201. So I'm now tinning the pads to install a new cap. Alright, so I'm going to get some capacitors. So I need 3. So 201, 0201. Right, so those are picofarads. Yeah. All right, there we go. Check the box. Alright, so I'm going to see if I can find a 0402. That's 0201. Oh, here's one. What, the black one? Am I going bad feet? Oh, Run Hill. In the shop now? Now do something, now fit up, now something to focus right now, set up the front shop. Oh, it finished. So around the back there now is repairs and sales on the front. Alright. Okay, so I think I'm finished with that part there. So what I'll do now, I'm going to catch all of these 4 pins here. 1, 2, 3, 4. They're all connected to the same source. So I'll use a thick wire because this has a lot of voltage and a lot of current. A lot of voltage and current, so I can't use a thin wire, so I'll just use the thick wire here. And then I will fly a wire All right. From this cap here, right to here. Let me melt this coating here so I can get more length. And I will align it right on top of these 4 pins here. It's already catch some of them already. It's in a hurry to be soldered here. There we go. Now I'm going to use a blob of solder now. I'm going to create a nice blob of solder and connect all 4 pins together as one. Alright, there we go. Oh, don't want to touch the first pin. There we go. 1, 2, 3. Ah, there we go. So I now have all 4 pins tinned with a, or we have one more, sorry. Let's see if I can catch the 4th one. Ah, there we go. So all 4 pins now are now joined. As you can see, they are now joined together. And that's what I want. So I'm going to just cut it with the stencil knife. This one is dull. Or I can just go back and forth like this until it's broken. I want it to break right in the joint. Ah, so it's broken right in the joint there. Alright, so I'm going to clean it in some 99.9. And I'm going to add some more UV right in that area here that I don't want any grounding in the future. Before, let me see if this is going to display first before I do that. So let me connect this back into the case. Let me just make sure that these capacitors are nicely joined. Oh, I create a bridge here now. Let's put my that cap. Alright, so far I have done everything. As you can see, the nice joint there with the 4 pins, and all is intact with these coupling capacitors here. So I'm going to sorry about that. Whoa. Alright, so I'll now check the resistance again. and I get 389, 393, 396, 95. Oh, it's getting slow. So 393, 94, 95, 96, 97, 98, 99. Let me blow on it. It's now 400. Let me blow some more. $401, 2, 3. Alright, so we're good. Alright, so putting this thing back into its case. See, we have liquid mark here. This is a liquid damage unit. This is rain, right? It's caused by rain. I'm just cleaning it. Let me check on this side of the board. Hey, look at this. See that? We have liquid here on the board. That is why I have to look back. So we have some liquid corrosion here, as you can see. And this is the Thunderbolt chip designed by Intel. And this is the ThinkPad engine chip, which stores the supervisor password. And it's acting as an embedded controller as well. Oh, it's only the embedded controller. This is the ThinkPad engine chip, which is the embedded controller. And it also stores the supervisor password, where that padlock, when you turn it on and there's a lock. So replacing this chip shall clear the password, right? If not, then you have to get a modified BIOS, right? Get a modified BIOS where you're going to modify the ThinkPad engine serial code, right? And handshaking signals from this BIOS chip to trick this chip to access the ROM that's inside of this to wipe the password, right? And that takes some engineering skills to do, right? So normally we just replace the ThinkPad engine chip to remove the supervisor password. This is the Thunderbolt chip. This is going to talk to the Type-C connections, so you can pass HDMI signals, USB signals, audio signals, and other signals, because it uses a differential signals, right? So this is used by the Thunderbolt, which has PCI Express 4.0 specifications right inside of this chip, right? As you can see, here's a ROM chip for it. So this is the ROM chip, right? It's a supply, reset and clock. Here's a crystal right there, and it is a ROM chip. Configure the GPIO pins, then it will talk to the charger to pass differential signals, not voltages, right? This is a chip that is used to pass voltages. This is a power delivery chip, as you can see here. This is a MUX power delivery chip designed by Texas Instruments. So I'm just going to clean here. Alright, it's now cleaned, as you can see. Nice. Alright, so I'm just checking for any more liquid corrosion on the board. And it's all good. Remember, this burn was caused by liquid corrosion due to rain. Alright. Very good. So we are set. So I can now apply power, and I can now power the unit. Alright. And then so let's see how it goes from there. I think my camera needs some adjustment. Yeah. So I'm now 1 hour and 42 minutes in the stream. I think I'll go a third repair if this is fixed, and then I'll conclude. The live stream. Right, so luckily that the flex cable wasn't burnt, else you'd have to replace it. Let me just clean it. See a little black shade of some corrosion there. All right, seems clean. That's fell off. Alright, so it's plugged in. Nice. And tight there. Alright, so I won't assemble it all the way. I'm just going to connect the basics. So we have the Wi-Fi there. This piece here should be like this, I believe. Alright, shall we? Ready? All right. All right, so I'm just going to hold it like this so you can see. All right, so I'm plugging in the power now. Oh, I plugged out the power. All right, let's... All right, so let's see what we get. All right, so I'm not seeing any fire. There's no spark, which is good. It's not turning on. It's not turning on. Could it be that the screen is burnt? Let's check back the resistance again on that line. Yes, we have a short. So the screen is burned. The cable is also bad. Oh my. Let me remove. Uh-oh, I created a short now. Oh, it's restored. Oh, we don't have a short. I thought we had a short. I was checking the ground pin on the back of the capacitor. Let me check again. Oh, we don't have a short. It's not shorted. We get 399, 400. It's not shorted. So why it's not turning on? Let's see if it is boosting to 20 volts first. I think I'm gonna put a screw here just the board don't slide out. Here's the screwdriver. Where did I got the screws from again? Right here, yeah. Alright. Alright, so it's boosting to 20 volts. Fan is spinning and stopping. Hey, fan is spinning. But I'm not seeing anything on the screen. Let me wait first. Since it's an Intel CPU, set us reset the art. Hey, we have picture. Ha ha ha. So as you can see, that's a done job. So it's starting up again. So you can see. Let me connect it properly. Alright, so I'm turning it. Oh, it's not plugged in right. Hold it, hold it, hold it. Hold it, hold it. Why is it behaving like this now? Ah. Did we have picture a while ago? Let me see what is going on. Let me connect everything. I think I'll do another repair after this. I'll make it 2 hours, 2.5 hours. Who's gonna sit and watch a live stream for 2 hours after playback? For the Acer? Wait, they never tell us, say, never tell them, say out of town. It's not turning on for some reason. I don't know why. We just had it turned on a while ago. Let me double check. Let me check back my resistances again. All right, I have 370. It's good. It's good. But why it's not turning on? All right, let me tilt it again. All right, so it's it's turning off. It's not boosting. It's not boosting to 20 volts now. All right. Is it boosting? Let me check for any more corrosion. Let me the battery. Let me see if it needs a battery. If it needs to sense the battery, then all is well. Alright, so I'm just connecting the battery. Adding the screws for the battery. Alright, so alright, so it's boosting and shutting off. It's not staying on. It's not boosting. It's boosting and shutting down. Boosting, shutting down. Let me check for shorting. But it was turning on. All right. Oh, screw fell. All right, let me see what's going on here on this board. Let's go under the microscope. Let's inspect the area that had liquid for the Thunderbolt. Let me see what's going on. All right, so all is well here. All right, so the Thunderbolt chip is fused with that epoxy from the factory there. Just looking here. This is the over voltage protection chip for the Type C data line and for the V-bus main line. Right, so these are connected on the V-bus line and it's also connected to the data line. So let me check the resistance on the data line and the USB line. This one is, I wasn't expecting this. So I'm gonna check some resistance here on the USB line. So I have VBus. I get 512 for VBus. Let's check data plus, data minus. 499, that's good. Excellent. Data plus and data minus, that's good. Let's check CC1. CC1 is good. CC2. CC2, excellent. Ground. And we have ground. So there's no fault here on the VBus and data line. So let me plug in the charger again. As you see, as it boosts, it shuts off. I don't know why it's behaving like this, and it was actually turning on before. Alright, so let me inspect all the rails. Let me check. Only this side had the liquid damage, so I don't see why it would have that problem. Let's clear here. All right, that's good. Alright, plug it in the charger now. Well, the laptop was working perfectly fine before. Shuts down. Shuts down. Power cycling, same thing. Just checking for any additional liquid corrosion. Alright, this is a power delivery. This is a HDMI output display converter MUX chip, which takes the DDI signal and transmits it into TMDS, which stands for transmission minimize differential signals, which is used to transmit both audio and data and video signals. As you know, HDMI. Let's check in here for any corrosion. Alright, that section is now cleaned. Alright. And this is another over voltage protection chip for the A and B, for the next the USB-C ports. So this over voltage protection chip monitors the over voltage and over voltage protection. This chip is for the over voltage protection, and this is a MOSFET that is integrated inside of this chip. And this chip will take the 19 volts, right, and pass it and becomes VBus, right? VBus, VIN, VBus, and convert it to VBus VIN pin. So let's check here for shorting. This chip normally breaks. If liquid catches this chip, then it's going to be very difficult for it to be turned on. This chip is a glass chip. So I'm checking the output, and I get 520. Let's check the input. I don't have any point to check, so I'll have to dig into the via here, and I get 151. Right, so I'm going to plug in the charger now. I should get 5 volts here. Is 5 volts coming there or not? Let's check. So we get 0.3 volts and it's going. And output is not, we're not going to get any output. Right, as you can see, I'm getting 0.2 going away. It comes, it goes away, it comes, it goes away. So I'm going to remove it and see what I get. First, let me check the power delivery chip first to see if I'm getting any shorting. So here we have some crystals here, right? One for each USB type. We have USB A, and we have for B, right? These are integrated MOSFETs as well. If any of them break, also can cause this phenomenon. So let me just clear it some more with some 99.9. I don't like the look of it at visual inspection. Alright, let me dry it with some hot air at 300 degrees or 290 degrees rather. Just inspecting the other areas here for any burns. Alright, so I'm now just hovering the hot air over the circuit to dry it properly. And there we go. There we go. I'm going 2 hours in the stream. And it's turning on. It's now boosting. And it's on. So let me put this back into its case. Oops. You remember this part. Now let's put it back into the case. I'll just connect the minimal stuff at the moment. Alright, so screen is in. Alright, so I'm just going to keep it here for now. Alright, so I plug in the charger now and it's on. Fan spins nicely. Hey, this camera is dead. There we go, we have picture now. Alright, so it's now turning on again. There we go. We have picture on display there. Let me just set back this camera. There we go. So now I have 1.2 ampere of current there, 1.25, and it's fully on. So as you can see, that's a done job. So it was the fault there on the power delivery chip there, on those two crystal MOSFETs. That's causing the problem. So as you can see now, it's fully on and it's in the overhead camera. There we go. Now we have picture there, so as you can see, that's a done job. Did it again. Alright, so I'm going to allow the technician to take this apart due to time, and I'll do one more repair and then conclude the live stream. Alright, so let me just connect back these connection here. Yes, sir. All right. Well, all of them so far seems like a walkover. You see that? All of them so far seems like it'll be. You see here, make them look easy. Rain the half a tree. Yeah. You see, for me, you see here, man. There's no way you could have raided them at all. Dovey! Dovey, come in and Dovey, make you go down there, Dovey. You know who said that? Hmm? Eh? Eh, me? No, man, me said that. You know? No, Davian, man. Dovey, come in and Dovey, make me go down there, Dovey. Yeah. Yeah, man, that no go do. Yes, I give a jump start. Feel like I'm that piece of Kentucky now. Yeah, you know, so I call it, man. Alright. Yes, I give a jump start. Oh, one screw you drop on the ground and stuff. Yeah. I'm not full on it neither. I just feel free. But we have a hard drive in it, so why it's not booting? There's an SSD there. Eh? But we never do anything in the BIOS, we just solder the wire. Oh, I was supposed to press F1. It was my fault. It was my fault, Heron. See some more liquid here on this connector here. The connector is for JNFC, not important. Right, fan is connected, audio is connected, power switch is connected, right, and the auto I/O board here is connected. All right, so let's do connect the keyboard, and then I'll make you then move to the next one. We are now 2 hours and 6 minutes in the repair. Wow. No, you're gonna just let them. You no response for them. You just want me get them. That's it go. Yeah. Just want me get them, you know. Come on, them do them there. But their job is to just transport them to me. One, which is good because I'm under a lot of pressure. This one's for this side. I think it don't screw up now anyway. And the battery is charging. As you can see here, I'm getting 2.8 volts. So all is well. From the battery is charging on a laptop, then you know that you have done a successful repair. So the battery is charging. I'm taking 3 ampere there, as you can see. 2.9 ampere, 2.96 ampere, 3 ampere there. And we have display, right? So let me just press the escape key there. and then allow it to do a clean boot right from the UEFI. Alright, so that should conclude that one. I'm going to do another repair, and because the stream is now over 2 hours, 2 hours and 8 minutes. There we have the Windows 11 starting up there. So that's Windows 11, as you can see. Give it a little zoom on that one. Let me lower my camera tripod. Alright, there we go. So we have display there, and we are at the login screen, and we are in the desktop. So that's a done repair. As you can see, that's a successful repair there. And I've done it again. So I'm going to do another repair. So I'm just going to shut it down. So that one was a burnt LCD connector catching back those 4 wires for the LCD screen backlight power supply. And this is a 4K screen. As you can see, we counted the amount of coupling capacitors there on the EDP display line. Right, and as you can see, it shows very pretty to ISP, which is a 4K, which can go up to 1440p, right, or 3680 by 2080 pixels, right? So we're going to do another repair. You can take this one. This one is in the box. Oh, this one here. Ah, this one. All right, this one is on no power. This one is no power. Let me see my stats on this stream. I have 4 lights. I have 4 concurrent viewers. Beautiful, beautiful. All right, so this one is a no power, we said, and this is a Acer Aspire. It's a 7th generation. All right, let me plug in the charger to see what the current consumption is, and see if we can fix this. Alright, so we don't need Type-C supply anymore. We need an Acer pinout. Oh, it's on the other side? Yeah, it's on the other side. So I'm plugging in the charger now, and I'm not getting anything. I'm twiggling the wire, feeling it around, but I'm not getting any current. Oh, it turns on. We are getting 130 milliamp. Are we getting? We're getting lights. Screen is flashing. Are we going to get that display? Yes, we have power light there, and we have a charging light. We have 600 and we have 1.7 ampere, 1.4 ampere. The screen is getting dark. Ah, what was wrong with it?
Nothing.
Wasn't turning on?
No. Let's see.
So you're saying I have this all this time?
When you put it up, no, when you put it up on this earth,
All right, this one is working. This one is working.
everything up with everything.
Interesting.
So, where it going?
And the battery is charging 1.3 amp. I press the switch again, it increases to 1.8 ampere. All right. Then we'll move to something else then. This one is already working. All right, so this one now is not detecting the eMMC drive. Where's the chassis? So I can turn it on and see what's going on. All right, so this one is not detecting the hard disk. This eMMC drive here, it says. We all know they tend to go bad after a period of time. The read and write cycles sometimes go to its maximum read and write cycles. So this is the eMMC, as you can see here. All right, is this a Chromebook?
No.
Oh, it's a regular AMD. As you can see, we have an AMD RAM. So we have an AMD CPU here, which is the This one is the Carrizo, right? This one is the Carrizo, which is the successor for the Kabini AMD CPUs, right? And this is the eMMC drive here. So they said that it's not booting up, it's not detecting it rather. So let's see what we can get over this thing. Alright, so I'm now connecting it into the chassis because I want to see the problem for myself. Alright, so this one is behaving like it doesn't want to go into its case. Why? Where's the heatsink? You take it off? Alright, so I'm just going to connect the display. Alright, so this is the heatsink. Oh, I forgot this one. I have to hold it. Alright, so I'm gonna give power. Oh, the power button is separate? It's in the keyboard, good. Alright, so I give power, pressing the switch. Alright. Okay. So, it's loading. Really? So it's a long drive. So, why is it loading there though? So you go into the partition screen and it's blank.
Yeah, blank. You don't know what this one.
So that's what it's gonna do. Alright, so let's go into the BIOS then and see if it has keyboard, power button in the keyboard. Oh, we're going to have to use the yoga button here, right? Yeah. Yoga, the yoga. Alright, so we're going to the setup, BIOS. What? Didn't I select BIOS a while ago? Aggressive win. BIOS setup, right? It's not going in. It's not going into the BIOS setup.
Yeah, but not further on, no.
So why it's not going into the BIOS? Let's try again. Let's go boot device menu. It's not going into the boot device menu. That's weird. Alright. I'll have to flash the BIOS first. That's the insect here. Some insect business right here. That's an ants. Right. Just doing some inspection here. I'm not going into the BIOS and I can't go into the boot menu. Alright, so I'll clear the BIOS first. Alright. This is a S515-1. I'll have to go on the mini computer here. All my biases are never come over how comes. I'll have to copy them. I have to stop the stream now. Never stop. Stop the stream, yes. Alright. So I will now stop the stream because it's now 2.5 almost hours. So I will conclude the stream until another time. Alright.